So yes, brought to you by Black Hills and ACM. Yay! And as John was saying, we're really thinking of making this a series. So if folks are into that, give us a heads up. Let us know. There'll be some information on how to go about getting a hold of us first. But I wanted to kind of run through like why we do these, because this is something that like John and I chat about a lot. Because when you and it's funny because we'll like attend somebody else's webcast on occasion, and it's very, very different. We were talking about the like missing banter. They also tend to be, hey, this is what we sell and come buy what we sell. And yeah, we talk about that a little bit. We got to keep the lights on. But at the same time, we try to focus more on the tech side. And, my analogy is down the bottom. It's like a car. If you don't know how your car works, when it makes a noise, you're going to pay a lot more to get that fixed than you probably had to if you don't understand how it works. So what we're trying to do is convey that information you need to make good choices about the tools that you're buying. As my kids heard their whole life growing up, we need to trust you to be able to make good choices. So like I said, thinking of making this a series. And if we do make it a series, would love some ideas on which ones to cover next. DNS Cat 2 is one of my personal favorites, which is, hey, why we're covering it first. But there's some other cool ones out there that we can go through and talk about. And as John said, I'm going to share a link at the end of this so that you can grab the pcaps that I use. You can go back through everything that I've gone through and done if you'd like to, just to try and reproduce it. Maybe you find stuff I didn't. That would be awesome. I'd love to hear about that because, one brain only finds so much. But we're going to start off talking about DNS Cat. And one of the things I love about DNS Cat is that it's really good at getting out of environments. When you think about an attacker has gone to all the trouble to compromise one of your internal systems, they want to make sure that software can reach back to the command and control server. Your network's a black box. They don't know for sure how they can get out. So what can they rely on? Well, so long as you're sending DNS compliant messages to the local DNS resolver, that will probably relay it out to a command and control server so you can get out from there. So DNS Cat 2 leverages that capability. It has a bunch of different query types. It goes in and cycles through. We'll look at some of that as we go through. But that's what allows it to communicate back to the command and control server. It can communicate with it directly and circumvent all the DNS, but that's much easier to tag. It's when it follows the normal DNS trail that it becomes really hard to try and tag. And by follow the normal DNS trail, I mean exactly that. So I have my internal compromise system here. It's sending a DNS query to the local resolver. Because it's DNS compliant, the resolver looks at that and says, okay, where are you trying to go? All right, I don't know where the name servers are that authoritate for that domain. Let me go to the root name servers, work my way down from there until it finds the name servers for that remote domain. And those name servers are actually the command and control servers. So the query that comes in lets the command and control server know, hey, that's one of my minions, and my minion's looking for marching orders. What do you have for me to do next? So it will either tell it, go back into sleep mode, or hey, go grab all the local Excel spreadsheets or whatever it is you want to have the thing to do. So here's an example of what it looks like when it's doing a direct connect. So this is some TCP dump output. You can see I'm connecting to an IP address out on the internet in this first packet. It's not connecting to the local resolver. It's an MX query, so it's doing a mail query. That's kind of interesting. As I've said, it does CNAME. It also does text. We'll look at those a little bit later too. But a couple of giveaway signs here. One is when it does a direct connect, it always puts DNS Cat right in the payload. So any IDS would be able to kind of pick up on this. Another thing that's kind of interesting with this is the response that comes back. You get one answer to your question. So we did an MX query against a host name. Number one, that's really odd today. It's ROC compliant. And in fact, I'm old enough to remember when we used to have mail delivered that way. You would actually have mail delivered directly to your local system. But we don't do it that way anymore. It's always to the domain itself. So for someone to do an MX against a specific host name, it's legal, but it's weird. It's something that's probably worth taking a look at. The other thing that's kind of odd in this is if I look at my name server records and my additional records, they're both set to 0. Again, it's legal. It's just odd for a system to not hand that information back just in case the host may need it, so it doesn't need to do an additional lookup. So this is DNS compliant, but there's a couple of telltale signs in here we can kind of key in on. Now, here's a connect going to the local resolver. So this is, east-west traffic staying on the same network. This one's a CNAME query. This one's a text query. And you can see I've got a really long host name in here that I'm going in and querying, and we'll talk about that one later. Out at this domain here, honestimnotevil.com. Yes, I could not believe that one was available to register, so I had to snag that one really quick. But it's doing a CNAME query. Again, when the answer comes back on this one, no additional records, which is especially weird for a CNAME, because with a CNAME, I'm saying, hey, I want to know what's associated with this alias. Well, you kind of need the additional information to get that too. You're going to be doing multiple queries. So again, a lot of odd stuff in here that we might be able to kick into. So looking into the headers, sometimes into the payload, we can probably tag this stuff. MXs that are not going to the domain but are going to specific hosts. We said those are weird. Text going to a specific host is not really, really odd, but it is a little odd. That's another one that might kind of pay off for you a little bit too.
I got a question on that one. You said that text going to a host is not really odd, but it is somewhat strange.
Yep.
What are some legitimate situations where you would see a text record actually being used?
I have seen, there are hosts out on the internet, and it's funny, I dragged this out of Bill Stern's database. There are hosts on the internet that still publish text records associated with the host to identify what services are on that host itself. So if there's a host out there that you don't know, is it a web server, is it an FTP server, what ports are open, some people actually populate the text files to be associated with that. I'm not saying that's a great idea, and I'm not saying it's common, but I have seen that on occasion.
Well, and for people that are interested, Bill does a tremendous amount of research for active countermeasures, and he's released a tool called Passer.
Yeah.
And I just put that out in the text, in the chat. So you guys can look at what Bill does. So whenever we say Bill found this out in the wild, it's usually with something like Passer, a tool that he's released open source. So check that out as well.
Yes, and we all have faster internet in the US this week because Bill is over in Tokyo.
That's actually not a joke. Like, how many wireless routers has he killed just visiting your house?
2. He has killed, actually, it was a border router and a wireless access point he's killed visiting my house. There's been a number of public events where all the bandwidth went away and they're trying to figure out who it is. And I just went over and told Bill, stop it. And when he shut his machine, the problem went away. Yeah, Bill's a madman. Bill's a madman, which is why we hired him. So.
Yep. And Mike just popped up and he said that Cisco actually uses the text records in their Expressway products as well.
Oh, good to know. Good to know. Hey, so while we're here, any other questions?
No, so far so good.
Cool. So one of the ways we can go about trying to tag this stuff is to look for beacon-like activity. Look for these things calling home on a repetitive basis. Let's start with what is a beacon? A beacon is a automated, non-human process that's connecting out to some host out on the internet. Doesn't necessarily mean it's evil. And I'll give you a great example, NTP. If you're on a Linux system, or actually specifically if you're on Ubuntu, every 15 minutes it will call out to an NTP server and it will do it with exactly the same session size every time. So on a very specific time interval, it will send a very specific message size. That's like the epitome of a beacon. But that's also the epitome of a beacon that is not actually evil. So we need to be able to whitelist out stuff like that. But when a system gets backdoored, that's the type of behavior we're actually looking for. We're looking for that software calling out to some host out on the internet. And there'll be other characteristics involved with it, obviously. You won't be able to identify the application layer as being NTP, obviously. It may, vary its interval and do some other fun stuff that we'll go through and we'll kind of talk about as we go through. But one of the ways to start looking for these things is to look for any signs of beacon activity on your network. Now, I've got a couple of pro tips down the bottom, and it's basically start with the most obvious things first. And, I know a lot of folks are probably sitting back and saying, well, if I wrote my backdoor, I would make sure I didn't show up on that. And hey, that's great. But you figure you got to start somewhere. You might as well start with the most obvious because that's the easiest to go in and kind of pick apart.
And Chris, that's really interesting. There was a huge Twitter conversation. I don't even think I've had a chance to talk to you about this yet. There was a huge Twitter conversation on domain fronting and a lot of these different techniques. And it basically boiled down to Tim Malcolm-Better at Walmart kind of kicked this thing off. And it seems from what we're seeing and what people are talking about, that a lot of the techniques that are being used by red teams and penetration testing firms are way far on the more difficult to detect spectrum than the actual attacks that we're seeing. So, if people are always playing that game of, well, an attacker can make a beacon once a day, yeah, they could, but that's actually a useless beacon to most attackers. So, like you said, it's start with the low-hanging fruit and work your way up. Don't automatically start with the assumption that it's the most difficult thing in the world to detect.
Yep. And quite honestly, going after the most difficult stuff first is going to take you the longest. The stuff that's really noisy, that's usually the easiest. If it's not evil, it's the easiest to make go away, and it's the most obvious. I'm reminded of one, and John, I know you were involved with this. We had a customer that had HVAC systems that were calling into a central console, just basically to say, hey, I'm online. Here's what I think the current temperature is. Here's what I'm set to, and I'm in a run state. And someone did a misconfiguration where it was supposed to call in once per minute, and it was calling in once every millisecond. I hate it when I get that decimal point wrong, but it was literally the most noisiest things on the wire. But number one, it was easy to kind of run down what was doing it. Number two, it was also easy to fix, and they got some free bandwidth out of it, which was kind of nice. So don't forget about the side benefits of these things. Sometimes it might not be evil, but you might be able to make the IT world a little bit better within your environment as well. All right, so we're going to start with one of my favorite tools, tshark. Yay. I love tshark. Don't get me wrong, I've been a TCP dump user for years. Anybody who's gone through my SANS classes probably learned more TCP dump than they ever thought they would ever need to use. But I really love tshark, and I love tshark's ability to be able to say, these are the specific pieces of information I'm interested in. Ignore everything else, just show me these things. So what I've done in this here, my -T fields allows me to identify these are the specific fields I want to say. Source, destination, IP address, okay, that's pretty straightforward. I'm also going in and I'm saying, I want you to show me the protocol that's being used. We're using protocol 17, that's UDP, which port number, and for our purposes of beaconing, we're looking at what's the session size. Now, since this is UDP, it's just the size of the packet. And what is the time spread interval between each transmission that's taking place? Now, notice my top line is 0. I'm going to need to normalize that out before I go in and do any types of statistics. So everything else is that time gap that took place between it and the session that was seen just prior to that. And in this case here, I just ran it through head so we could see a couple of lines of output. But ideally, what you want to do is take this and redirect that to a file, because once it's in a text file, hey, you can do all sorts of nasty things with it. Like leverage the cut command to go in and say, okay, I want to look at this one specific field within that file and identify for me how many packets am I seeing associated with each protocol. It's kind of nice to be able to go in and get a quick protocol breakdown. What ports are being used. Now, when I look at this file, I see most of it's UDP. I do have 2 packets that are based on TCP. Okay, that makes it interesting. I'm going to want to take a closer look at that one in a second, but they're all associated with DNS. So, where do I start? For me, the most obvious, let's go in and kind of start with the TCP. Now, when I go in and I look at the TCP, I can see my internal system was sending to port 53 on some host out on the internet. Okay, that's odd. My system, my local host should not be doing direct connects to DNS servers out on the internet. So that kind of makes this one stand out a little bit. But also notice I'm seeing the 2 packets are 2 SYN flag packets. I don't have a SYN ACK coming back, which tells me my system was trying to connect to that port. There was a firewall in the way, or there was something that was making the SYN packets go away before it got to that endpoint, because I don't see a reset packet coming back telling me the port's closed. So what I did here is I used grep to say, okay, that text file I created, -v any TCP traffic, so -6, get rid of all the TCP traffic, and now I'm just going to look at the beacon data set as part of the UDP trail. So as I said, the first thing I want to do is go in and delete that first line. When I go in and look at my stats for timing, that's going to kind of skew things a little bit, so I want to make sure that doesn't happen. So I just went in and I said, okay, VI the file, delete that first line, resave it, and now we're ready to go in and do an analysis. Now, there's a couple of ways you can go about doing this. You can import it into a spreadsheet. You can play around with it if you want to. I like to keep it on the command line as much as possible, just because that means I can go through and I can actually do an analysis and then save the data off without it taking any manual entry. In other words, it's real easy to go in and kind of automate a lot of this stuff. So what we're looking at first is we're looking at the statistics based on the session size. So we've got a minimum session size of 89. We've got a maximum session size of 290. We've got a mean, which is behind my camera, 89.9, 89.8. Okay, so the first thing that grabs me here is my mean is very close to my minimum value. What does that mean? Well, we had 108,000 data points here. That means that an overwhelming majority of those 108,000 data points are closer to that minimum size value. Now, stop and think about how a beacon normally works. A beacon is calling home saying, hey, do you have anything for me to do? No, go back to sleep. Do you have anything for me to do? No, go back to sleep. Okay, that tells me that if my mean is close to that, if a majority of the packets are close to that, that could very well be a beacon signal that I need to go in and look at. And notice my standard deviation is pretty small, which means that my cluster around that mean is pretty small as well, which again leads me to feel like, yeah, at least based on size, I think I'm looking at a beacon here. Now, a max size is 290, so something was much larger than that. What does that tell me? Well, if I'm seeing a min size of 89 and I'm seeing a majority of the time my mean, I'm around that 89 size, but I have a 290 in there that's kind of an oddness into the data set, that tells me that at least once this beacon may have been activated over the previous day. I don't know where or when or how or anything else yet. I'd have to go back into the pcap to go digging for that to find it. But at least now I know there's something interesting there based on size. Which, by the way, when you look at a lot of the tools that are out there that go looking for beacons, size tends to get ignored. You know, we're geeks. We know this. You don't ignore size. Timing seems to be the thing that everybody keys in on. And yeah, timing's important, but you got to look at the size of the whole thing as well. So speaking of timing, yeah, so I apologize. My example here, I went in and should have deleted out the 0 and I didn't. So my minimum time gap is some small amount less than 0, but notice my time gap goes up as high as 861. So it's pretty high. I've got a mean that's close to my min, which again tells me, yeah, okay, this could have some beacon-like indicators. And my standard deviation is small, which again is another indicator that I'm probably looking at a beacon. So we kind of analyzed size to say, yeah, because of all of these data points, it looks like we got a beacon. When we look at timing, it's not quite as clear, but it's still leaning towards that, yeah, I think we got a beacon we got to pay attention to here. Questions at one point. What's in the beacon test file again? Let me back that up just a second. It is this information. So this file is that what I created with tshark to go through and just say, give me the IP addresses, but most importantly, give me the size, give me the timing. That's what she said. Yes, of course. Let's see. Was there any other questions in here I should jump on? John or Jason?
Yeah, the one that we just had pop up, we have, wouldn't using DOT or DOH means one cannot do any C2 detection on an external device. DNet traffic will be encrypted, hence the detection device would be useless.
Well, so encrypted traffic doesn't really matter. You know, so when we're going in and we're doing this analysis based on size and based on timing, notice we don't care if the payload's clear text, obfuscated, or encrypted. We're simply doing a size-based analysis on it. So, you know, again, encrypt the packet stream, it doesn't really matter. And this is kind of nice because some sites actually have privacy concerns to worry about, where if you're looking at other people's data in their packets, you know, that could be problematic. You can actually just go through, extract metadata and do all of this type of analysis, never look at the payload and stay clear of those privacy concerns.
Well, and we honestly stayed away from looking at the payload with Rita just because there is so much encryption. Gary asked a question, said, what about standard deviation? How small is small? Chris, correct me if I'm wrong, but the size of the deviation doesn't matter as much as what is the disbursement. If it's a flat bell curve or a balanced bell curve, that's far more interesting to us than how wide that distribution actually is.
Absolutely. And quite honestly, there might be ways to pull that out of R that I have not found yet. And if anybody has, oh my God, please drop me a tweet. Because I've just I've played around with this tool a little bit, but there's a whole lot more I know I could learn. So there may be a way to kind of figure out that dispersion a little bit clearer. You can graph it, and that makes life easier. And we've got a tool to graph it, and I'll show it later. But to be able to do it on the command line, yeah, that would be kind of nice.
Yep, and we've had a bunch of questions about the encryption. And once again, the encryption doesn't matter because we're looking at the payload, we're looking at the payload size, we're looking at the disbursement of the connection intervals and even the payload sizes as well. So just basically get the hell out of trying to look at the payload because we can encrypt it. We can also use steganography and hide it in things like view-state parameters.
Yeah.
So the further you get away from actually trying to analyze and make sense of payloads, the more sane your life is going to be.
Yeah, because again, it would still, yeah, if I'm hiding it inside of something, the timing, the size, that's still something I can go in and do an analysis on. So cool. So hey, we had a way to detect a beacon. So just script this and we're done, right? Well, maybe. This scales nicely for your home network, not so much when you're dealing with hundreds of millions a day. Because again, we just went through one IP peer set, one internal system talking to one external host, and that was it. We would need to do a similar analysis for every other session that took place across our perimeter over the previous day. Oh my God, that's a lot of work. So are there ways we can go through and kind of simplify this? Well, yeah, that's what Rita was for. So one of the reasons we came up with Rita was to be able to do this type of analysis and actually have it be something that's scaled. So this is an open source tool that was created on the BHIS side. It's now maintained on the ACM side, and it's specifically designed to go in and identify command and control channels, specifically beaconing, which we'll go in and we'll take a look at now. So Rita does not ingest pcap files directly. You've got to give its metadata. So the easiest way to do that is just use Bro. And Bro is another awesome open source tool. So you can just simply take a pcap file, or you can just run it and have it listen on the wire, ingest that into Bro. Once you have Bro logs, now just go in and import them into Rita. And once Rita has them, Rita can go in and do an analysis on them. And this looks like it's not doing much, but hey, this just answered all those questions we had about the mean and the standard deviation and everything else. We're doing all that math in the back end. And more importantly, people who are smarter with math than I am doing this in the math in the back end. So this very first value that you see here in the output, this is a how likely is this a beacon? Because it's not really a yes or no question because it's a gray area. So they do this on a scale of 0 to a 1. So if it's a 0, nope, definitely not a beacon. If it's a 1, yes, it's definitely a beacon. Most of the stuff comes through at like, 0.6 something or 0.8 something. This one comes in right at 1. So this is something that Rita looked at and said, oh no, this is absolutely a beacon. And you can see some of the values we've been talking about, like the number of packets that took place, the size that was involved. It shows up in this output as well. And we also have AI-Hunter, which is a commercial tool. It's cheap, but it is a pay-for-use that allows you to go through and do a similar type of analysis. And really what it comes down to is it'll ingest Bro logs as well, but there's a lot more visualization with this. So not only look at it as a beacon, yes or no, but is it actually a threat? We'll go through and we'll gauge that. And we also try to go through and give you some good visualization tools to figure out if it's a beacon. This is a 24-hour period of time here. If I can draw a flat red line like I did here across all of my 1-hour quantities of traffic that took place, yeah, that's definitely a beacon I need to go in and pay attention to. We also mentioned that when we were in looking at the R stats, hey, maybe this backdoor was activated. That's something AI-Hunter is designed for too. Here's my heartbeat. Here's my little signal telling me, yeah, somebody activated it and transferred 300 bytes. So again, we don't look at payloads. We can't tell you what it is. But 300 bytes, we're running about 90 off of a heartbeat anyway, so there's maybe about 250 bytes transferred here. That to me sounds like a directory listing or maybe a listing of what's running in what processes we're running in memory. It's definitely not, hey, here's a new rootkit I'm uploading, or hey, let me grab all the Excel spreadsheets. So we're still at a point where somebody's in a discovery mode on the system they compromised on you. If we can get them off now, forensics becomes a whole lot easier. Okay. So that is CAN DNS Cat 2. But let's kind of play around with this one a little bit. Let's say someone goes in and says, okay, I want to try and make DNS Cat. It won't be as functional. It won't be as easy to use, but it'll be harder to detect. We're going to go in, vary the timing, varying the size. We're only going to have it run during normal business hours. So again, I might want to inject a command to the system that I've compromised. And if it's not business hours yet, it isn't going to come back. Not like DNS Cat 2, which responds very quickly when you say, I want to execute this command on the remote system. Further, it may take the command and wait a while before it actually gives a response back. So this was just, hey, can I keep DNSCat2 in a functional state, but make it actually harder to go in and detect? So this will be the second file that you get as part of the tar archive we're going to give you at the end of this, suspectdns2.cap. So what this does is it's very similar traffic. As you can see, my size is a little different. The timing, at least initially, looks about the same, although it is starting to widen up a little bit more. The time dispersion gets wider and wider the longer it runs. But it's the same type of thing we did before. I'm taking a pcap file. I'm saying what fields in each packet are interesting to me. Source, destination IP, most importantly, size and timing. And now I'm going to redirect that to another file so I can go in and I can use my file manipulation tools to go in and do an analysis. So like before, the first thing I go in and do is look to see, okay, what's in here? What do I have for traffic? And this time I can see it's all UDP traffic, and I've got 2,074 packets sitting in there. Cool. So I've got something I can go in and I can play with to go in and look at just this one particular channel. So again, running this through R in order to go through and do a statistical analysis. My min, my max, fairly close together size-wise, but also notice my mean. So my mean on size is pretty close to my minimum, but look at my standard deviation. So this says, yeah, my average is pretty close to the heartbeat, but when I kind of plot out how everything kind of jumps around that mean, it's a much wider dispersion than it was before. It's not huge, but this is one of those gray area ones. This is one of those instances where you'd look at this and say, well, it doesn't really look like a beacon, but it doesn't not look like a beacon. I'm not sure what to make of that. And then you'd go look at the timing, and here's what the timing looks like. So I've got a minimum time gap that's very small. I've got a maximum time gap that's much, much larger. I've got a mean that's kind of close to the minimum, but not really. Our minimum is 50 milliseconds, and this is saying almost 2.5 seconds is my average, or is my mean. It's not that close. And, my standard deviation kind of says it's all over the place. So when I try and do an analysis on the timing, so when I looked at the analysis on size, I said, maybe, maybe not, I'm not too sure. When I go in and look at this would convince me even further, yeah, this is probably not a beacon. I've got other stuff to look at that's even closer. It would be really easy going in and doing this type of an analysis to look at this and say, yeah, this isn't something I need to worry about. Cool. Okay, so we're at the command line, we're not sure. Let's pull it into Rita. This is what Rita was designed to do. So let's import it into Rita, and Rita looks at it and says, nah, it's not a beacon. So yes, I purposely built this to defeat our own tool. I know that sounds weird, but I wanted to make a point of this. So yeah, Rita didn't detect it as a beacon. It didn't figure out it was a backdoor. So are we out of luck? Is there anything else we can try and do here? Well, yeah, if we can't detect it as a beacon, remember back at the beginning of the webcast, I was kind of talking about there's oddities we can go in and look for. Things like, hey, you're doing an MX query against a host name or fully qualified domain name instead of just a domain name. That's kind of weird. We may be able to go in and kind of look for those types of things. One of the biggest ones we can key in on is how many fully qualified domain names are being resolved as part of that remote domain. And give me a second to kind of talk you through this one, because this is kind of a key point with this stuff. Because when you look at, we're talking about just DNSCat2, and we said it uses C names, it uses text files, it uses MX records. But in the wild, we've seen IPv6 quad A queries being used for command and control, meaning that what comes back looks like an IP version 6 IP address. And then when you look, you see, no, wait, no one's been allocated that yet, or it's a private address. That's something that would never get handed out. And it turns out, oh, no, wait, that's command and control. We've seen people doing a query against DNS keys, so DKIM. They're going in and saying, hey, I want the keys to be able to authenticate that domain. And what comes back is invalid keys. What it actually is again, a command and control channel. So we were talking about CNAME text and that type of thing. But oh my God, there's just so many ways to skin that same cat here with DNS. As I said, domain name keys, I could use that. IPv6 addresses, I can use that. So how do we try and find a methodology that will let us catch everything consistently? Well, we need to find the weakness in using this as a command and control channel. And the weakness is DNS catching. The weakness is, as a compromised system, I need to make sure I'm always talking to the command and control server. So I'm going to take a DNS query, I'm going to send it to the local resolver, and it's supposed to forward that request on. Well, I got to make sure that resolver doesn't cache it. Now, one of the things I could try and do as the bad guy is I could say, okay, when you did a lookup on this fully qualified domain name, I'm going to set the TTL to that to 1 second. Some small period of time so that the local resolver knows, don't cache this information. Well, here's the problem with that. DNS software ignores those settings for the most part, at least the minimums and the maximums. You can go in and you can say, age this out in 1 second, and the local resolver will say, nah, the admin configured me to remember everything for a minimum of 5-10 minutes. So even though the TTL comes in set to 1 second, it'll reset it to a 5-minute period of time. Okay, now I can't talk to my command and control server anymore. Now I'm only talking to the local resolver. I'm broken. The other thing you can do is you can say, hey, remember that record for 30 days. And again, the local DNS server might say, no, my admin configured me not to remember anything for that long. I'm not supposed to remember anything more than, I think Microsoft's default is like 24 hours. So, again, so even though you can set TTLs, local resolvers can override those. So how do you make sure the resolver can't break your CNC? Well, the only way to do that is to change the lookup you're doing every single time, meaning that I'm looking up a different fully qualified domain name each time. Well, this creates an interesting situation because think about how many fully qualified domain names will normally be advertised as being part of a specific domain. Think about like your own environment, and you can probably like count on 2 hands, maybe just one, how many hosts that you advertise to people on the internet, right? You've got a web server, you've got a couple of DNS servers, you've got a mail server, maybe a customer portal, and probably not much more than that. So that 10 to 12 range, that's it. And then you get into the domains that everybody's heard of: Akamai, Amazon, Google. They offer services on the internet. They're huge. Everybody knows who they are. And they're probably in like the 500 to 600 range. If you're using them for their public cloud services, it might be up in like the 800 range, depending upon how many VMs you're running at any given time. But again, certainly less than 1,000. So anytime we see it, and again, this is not how many do they have in their records per se, it's how many of these fully qualified domain names would your domain find it necessary to go query within a 24-hour period of time. So again, to say anything more than 1,000 is suspicious, yeah, that's going to be suspicious. That's something I need to be concerned about. So could we leverage that to try and figure out when somebody's gone in and created a command and control channel? So I'm back at tshark again. Yay, tshark. And I'm going in and I'm saying, all right, I'm doing the same output I did before, although quite honestly, I don't really need it here. I just kept it in the slide for consistency. The important fields are these 2 new ones I've added: DNS query type and DNS query name, because that allows me to go in and say, hey, you guessed it, the query type, as well as what was the fully qualified domain name that was actually being queried. So notice we're looking at DNSCat. Remember I said it mixes things up. I've got a C name here, I've got a text here, another text, another C name, and an MX record. So it's revolving through a bunch of different things. That may be something that's worth going in and taking a look at. But I'm going to take this output now, I'm going to redirect this out to a file, and once I get it out to a file, I can go through and I can start manipulating with it. Now, just because you can do a thing doesn't mean you should do a thing, and I do that all the time. So we were talking about Bill Stearns earlier. One of the things that's awesome about Bill is he is the nicest person you will ever meet in your life. And Bill looks at some of the stuff on the command line I do, and he's really good at, oh, wow, Chris, that's awesome. Yeah, that's really creative. That's cool. Here's how to do it in 10 characters with awk. Here's a real simple way to skin that same cat. So
here's a lollipop for your efforts.
Yes, exactly. I get a lot of lollipops from Bill. Actually, yeah, it's a running gag. I used to have a whiteboard that identified all the things I've been able to teach Bill about Linux since I met him. I met Bill in 1998. I think that number's up to 6. Just very smart guy. But so I redirect all that output into this file. Let me kind of walk you through the individual commands here. So first I'm running cut, and I'm telling cut my comma is my delimiter for each field. So as you can see here, anytime I've got a comma, I'm changing from like the source IP to the destination IP and so on from there. So anytime you see a comma, that's going to be, a delimiter on a field. And I want you to go after field number 8. Okay, what was field 8? Well, if we count these through, field 8 is this fully qualified domain name. So it's this really long, convoluted, I can definitely tell a person didn't create that host name, followed by the domain name itself. Now, this is where things are going to get a little bit weird, because what I want to do is I want to go in and I want to look at anything that's associated with honestimnotevil.com. So I could go in and now say, okay, make the period my delimiter, but how do I make sure I only grab honest, I'm not evil and com without catching the fully qualified domain name in the front, especially since there could be multiple subdomains? So that's where Rev comes in. So I go in and I kind of sort this out and I run it through Rev. So what Rev is going to do is it's going to take all that data and just change it to MOC period LIV blah, 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 all the way out to the end. Now I said, okay, cut. This time the delimiter is the period, and you guessed it. Now that I have the domain name written backwards, I just say grab field 1 and 2, switch it back again so I can actually read it as a human, sort it, run it through unique-c, and give me a count on what you say. So what all of this is telling me is that in this period of time when we did this analysis, which I think this runs over about 2.5 hours was all we were able to get data for, because again, this thing had office hours, I had 2,074 fully qualified domain names that appeared within this domain. Okay, it's not Amazon, it's not Google. Gee, that's really suspicious. So do I know for certain what's going on here? Well, no. But I definitely know there's something weird taking place here, and I need to pay attention.
So, Chris, we had Sean ask, wait a minute, why reverse it again?
So the reason to reverse, well, if you can read it backwards, you're fine. The reason we're reversing it back again is so that it's actually still legible. So if you think about if I didn't have this in here, if I didn't have this, this one here to reverse it back again, what I'm going to end up with is a line that says MOC period LIVE TON blah, 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 all the way down to the numeric value, which the numeric value will also be backwards too. We don't want to have to read that. So I'm reversing it so that my com comes first, then my domain name, and then any subdomains, and then the host that's associated with it. So now I can go in and say, just grab me the first 2. Now, a qualifier with this. If mixed into this data was another domain that was honestimnotevil.com.uk, okay, this kind of breaks down. So you may have to do multiple passes to kind of weed this thing out correctly if you want to go through and try and do it this way. But I at least wanted to find some method to give you to be able to do this in the command line just with the raw data. This goes through and this gives it for you. Making sense, Sean? Okay.
I think we're good.
Cool. All right. So so you could do that, Sean. So Sean's saying, hey, what if you cut and you went in and you went look for fields 2 through 3? You could do that. You could ignore .com. That would still give you the kind of unique stuff, even if there's a country identifier in there as well. But it does make it much, much harder when sometimes you want to match on the first 2 fields, sometimes you want to match on like the first 3 fields. It definitely takes a little bit more to kind of sort through this. So I made it look, the only reason I brought that up is because I do this and it kind of seems like, hey, and look, this is easy. And it is easy for my canned data. In the real world, there's a couple of bumps you're going to run into you'll need to kind of work through, and that's kind of why I wanted to bring that up. But the easier way to do this, run it through Rita. Again, Rita's open source. Anybody can download this and use it. So we just take it as bro data, pump it into Rita, which we had already done. And remember, Rita didn't detect this as a beacon, but Rita did look at this. This time, instead of saying show me beacons, I'm saying show exploded DNS. Rita's saying there's 274 fully qualified domain names associated with that domain. That might be interesting. And then Rita goes on to list them all out for me so I can go in and see them if I need to. So, again, Rita might be a good choice here. And I can pull it out of AI-Hunter as well. So same type of data, just a different visualization you can go through and use. So what have we learned? Well, we've learned that backdoors like DNS-Cat2 can have beacon characteristics, but sometimes they might not. So we need to look for beacons, but we need to have other things to go looking for to be able to catch this stuff as well. And it can't be patterns. It can't be, I love Snort. Marty, awesome guy. I've used Snort forever. Yeah, IDS definitely has its place. But as soon as you all know, as soon as somebody changes the pattern, you start missing things. So how do we do this in a way that if they mix up the pattern, we can catch it? With DNS anyway, so long as we're looking for those fully qualified domain names and counting those up, that's a pretty consistent way to go through and catch that backdoor regardless of the type of query that they're going through and doing. So, it's kind of that, wax on, wax off grasshopper type of thing. Leverage their weakness against them. That's really what we're doing here. So to kind of give you a wrap up, so drop a tweet to us if you want to see this as a series. As we mentioned at the beginning, I was originally going to do 3 different backdoors. I got up to 80 slides and I was not done and said, okay, I don't think I can cover 80 slides in an hour and still leave time for Q&A. So we need to trim this back a little bit. I'm happy to kind of turn this into a series if folks want to. So we can go through different command and control channels. If you like this and you tell us, hey, yeah, I like that idea, please also tell us if there's a command and control channel you want to cover, dump that out there as well. Showed you a couple of things, AI-Hunter. John usually saves that till the end. I kind of mixed it in. I apologize for the little sneaky stale stuff as we go through. But if you want to see a demo, drop demo in the chat. We'll be happy to help you out. But more importantly, Rita, open source. Here's a link to get to it. So if you go to that link, you can grab a free version of Rita, and you can go through and use that. The pcaps I used in this webcast, there's the link to go through and get those. So webcast-files-downloads. Go to our website, go to that link. You'll be able to go in and grab the files from this, and then you can go back through the slides, which we'll make available in a couple of days, and you can go through and repeat all of this stuff. By the way, if you're watching this on YouTube as opposed to watching it live, that's okay. Don't feel like you missed anything. Tweet it out, throw it in the comments, YouTube comments. We check that area as well if there's any CNC that you want to say. And with that, I want to open it to questions.
Cool. We've got a bunch of people coming up. Is the website going to get a copy of the recording? Absolutely. You will all get an email about that. Is there going to be a recording? Yes, there is. Can we practice the commands? And if you can go back, although I love this, if you can go back one slide, all of the capture data that Chris went through is available, and that's one of the things that we're going to try to start doing as much as we can. One of the things Chris and I spent a lot of time talking about, and Bill, is there's a tremendous emphasis in the industry right now on tools, and a lot of the vendors are turning how those tools work more and more into this black magic.
Yes.
Don't worry what's going on with the tool. Just trust us. It's artificial intelligence. And and years ago, Chris, back in 2003, when I first met you in Denver, the emphasis, whenever you were talking about firewalls back then, was it wasn't enough just to say, here's a magical firewall checkpoint, and it does it. As security professionals, you have to actually know what is going on underneath the hood.
Absolutely.
And any vendor for any product that you implement, if they can't tell you how their product's working, then they're really trying to hide something. And I think the more intelligent, not even intelligent, but the more trained our entire community is, the better we're going to be. So yeah, back to the command line. There's been a lot of people, if we can just take a note for those that are, to Trevor C2, that was created by Dave Kennedy. And Trevor is pretty cool. It actually randomizes the interval in the connection intervals. And we'll talk about that specifically as it deals with skew and dispersion. And we'll deal with that too. We got a lot of people asking for demos, which is great. Can Rita turn pcaps into bro files? Nope, you've got to do bro first, and then Rita will pick it up. Or you can have your individual device throw syslog, or not syslog, throw IPFix or NetFlow data as well. Boy, we just had a lot explode as far as questions.
Yeah.
Are these tools, Chris, primary use on-prem infrastructure? Can we apply these methods to AWS or Google as well?
So with AWS or Google, you're going to have the VPC flow logs to deal with. With Microsoft, I believe it's, what do they call it, Packet Watcher or something weird like that, Network Watcher. That data is pretty similar to IPFix data. So it's still there. It's in JSON format. It actually means that you can use something more advanced than just regular text tools to go and manipulate it if you want to. But yeah, a lot of the techniques that we're talking about you can use in the cloud as well. You just have to turn on the public vendor's logging capability first in order to be able to get that to work.
Another question was, can you automate Bro to Rita to produce output into a SIM? Absolutely can. You've got to go through some weird steps to get that to work. You'll have to actually make a JSON query to the Mongo database to actually pull that out and ingest it into your SIM. AI-Hunter, on the other hand, it will actually throw direct syslog straight into the SIM as well.
Yeah, you could also cron Rita and run it through Logger, but oh yeah, that now it gets scary.
That gets, it actually sounds like fun. Kind of a weird,
it does sound fun, doesn't it?
Could we make it suck even more? Yes, this is awesome.
So can I need to tell a quick, funny Bill Stearns story again. So Bill was in my class one time, just kind of watching because he was also going to be teaching it. And I was talking about Logger and I was talking about Netcat and how you can use the two of them to, send log files off to remote systems. And I made the comment that you could not include the priority of the log with Netcat because there was no way to define it. And as I made that statement, I see Bill's head look up almost like a puppy. And he looked at me and he just kind of tilted his head. And then I see him look back down and starts typing away. And he wrote a wrapper for Netcat that allows you to pump syslog through it and set the priority value. And did it within like 10 minutes before the break came up.
Yeah, sometimes, that's Bill. And I shared a link out to Bill's website. If you can get a lot of the stuff is old there, but it gives you an idea of what Bill's background is.
Oh, if you want to learn about SSH, oh my God, there's some awesome.
Oh, the SSH tools. There's a ton of different things.
Yeah, and it's still relevant, still very relevant.
So Rohit had asked a question, hardware malware, and now we're talking about some really, really deep level, not even kernel level rootkits, but microprocessor level rootkits. Would you be able to detect those types of backdoors? And that's one of the reasons, Chris, that we went to the wire, right?
Yes, absolutely.
It sounds weird, but the wire is truth. Once we get on the operating system can be used against the defenders.
Guangzhou, China.
Yep, exactly, with the video cameras. And Brian, who I've known for years, is actually doing that with Splunk, where they're dumping their Rita data into Splunk as well.
Yep.
So cool. Can definitely do that. More people would like a webcast one day dealing with cloud logs. Wouldn't we all? And I think that there's a tremendous industry that's built around just the fact that cloud logging sucks. And there's vendors that try to make it suck less right now.
I see do you know offhand if Bro can import AWS VPC flow log format? To the best of my knowledge, Stephen, no. Bro just wants to see pcaps or live traffic.
Bill said, I had a SANS instructor talk about the amount of entropy in a fully qualified domain name to detect the CNC queries. And that instructor was actually Joff Thayer. And he had used a bunch of really cool algorithms to look at the entropy in the names. And that is a feature that we're looking to implement in Rita sometime in the near future. All right, so if there are no more questions, are we ready to wrap it up, folks?
I'm going to miss this Wegmans parking lot I've been in for the last hour.
There was a question earlier asking if we get to follow you around and go shopping.
Yes.
That sounds absolutely terrifying. All right, everybody. Well, thank you so much. We appreciate it, and we will talk to you all later.
Yeah, thank you, folks.
Thanks, everyone.